Hello everyone. Good morning. Am I audible?
Yes, yes. Good morning. You're audible.
Okay, thank you. Okay, 900. Yeah, Divya is there, right? Uh, Divya, can you hear me? If you're speaking, you're on mute. Okay, let. Where were we? This is the file that we need to go through today. Probability and theorem. Right. This is the file. Okay. Oh, we were there in conditional probability, right? Bayes theorem, total probability. Okay. Okay. We'll start from here. Few basic things
Sir,
that you need to. Yeah.
good morning, sir.
Yeah.
Sir, what we started yesterday, I did not attend the class.
Uh, we started probability and probability theorems.
We came too far, or sir, we are at the beginning.
Like we covered like 80% of the topic. Rest 20% we'll cover today.
Okay, sir.
Not a problem. This is basically not theoretical, but you have to practice something, and that I have provided. If you go to the video, you
Okay,
can
sir.
see I have provided the PDF file to practice. You need to do that.
In D drive, sir.
In G Drive. In G Drive, yesterday's session you can go through. So this session 15, module 8 we started,
Okay, sir.
and few of the things we'll cover today also. This redistribution and all. So basically,
Sir, too much disturbance is there from your mind.
is it like the wind is blowing?
Okay, okay.
This is wind. Not sure today is like heavy wind flowing here. Okay, now it is okay.
Good, sir.
So module 8, okay, module 8. We go through the sessions yesterday.
Okay, sir.
And this is the continuation from yesterday session only. So we'll see what is the time. Okay, 13, 12 people. 12 people. Okay. So let's start. Okay, guys. So
Okay, sir.
first of all, conditional probability we understood from yesterday, guys. What we understood conditional probability means, that means based on a condition, right? A given condition of B, or B is true. That is called conditional probability. And when we are using that concept in Bayes theorem, this is how it looks like. Recollect, right? So when someone will ask you conditional probability, what you need to say? Conditional probability is the probability of an event occurring given that another event has already occurred based on a condition. Okay. And it is denoted as a P of A pi B, right? Probability of A given B. That means here we're calculating what? Probability of A. And according to the conditional probability form, excuse me, guys. According to the conditional probability formula, What is this? Probability of A given B equal to probability of A and B both occurring, probability of A and B both should occur, divided by probability of B. This is the formula for conditional probability. Now, if you will derive this formula of probability of A and B, you will find this in Bayes theorem. That is what? Probability of A and B means probability of B given A into probability of A. This we already seen in yesterday's session, right? Bayes theorem. Now, what is naive Bayes theorem? Because you kind of get a question on each of this topic, like what is conditional probability, what is Bayes theorem, what is naive Bayes theorem. So naive part comes from, like, you can get a question like this: why Bayes theorem is so naive? Like this kind of question also you will get. So naive meaning, if you'll see in Google, what does this mean? Lack of experience, judgment, kind of. Uh, I'm not sure what you use in your native language. Kind of frickle, right? Or you can say like uh, not mature kind of thing, right? That's what I can think of, like naive here. So why Bayes theorem is so naive? They will ask you. Okay, why Bayes theorem is so naive? So naive Bayes theorem is nothing but this is a class. Actually, this is in machine learning. This is a classification algorithm. So we are studying all these things to do what? To implement machine learning algorithm in our day-to-day life and solve some real life issues. That's what our aim is here. Now, naive Bayes is a classification algorithm. That means what? So two types of problems you are going to encounter specifically for machine learning. One is classification, one is regression. Classification means you have to classify from the categories. Like suppose you have given a data of a mail, you have to classify the mail as spam mail or not spam mail. This is called classification because you are classifying the problem into category, different classes, spam mail or not spam mail. Now, what is regression problem? Regression problem is like you are not going for any class or category. You are going for a particular number. You are going to predict a number. Like what is the stock value? You are going to predict a number. What is the price of something? You are going to predict a number. So classification and regression, two different algorithms. Hope you will get more understanding once you cover deeper into the course. But just overall point of view here. Now here naive is used in classification algorithm. Okay, and it is used to predicting the probability of a class label given some input data. Like I said, mail data is the input data. What is the output? Spam or not spam. Now when I say mail data is the input, that doesn't mean like one data. It can be multiple data set in the sense multiple columns can attach to this data set. Okay, that means let me just 1 second. I need the writer here. So this is actually a fundamental question that I wanted to, as you guys want to know this in detail. So thinking to give you some, where is the pen? Okay, so what happens? Suppose this is a data frame and this is your data set. Okay, and in the data frame you have what? Different columns. Now this data x1, x2, so column name. Suppose these are the column name like this. Now what you are doing in machine learning, you are providing this whole data inside the machine or machine learning algorithm. Using machine learning algorithm, you are using this data and these are called your independent variable, every column. Okay, so this data when you pass to the model, and these are the independent variable, that means, so guys, in machine learning you are going to see these names are vary, okay, based on the, like there are different kind of names, like some call them as independent variables, some call them as uh, features. Okay, features x1 x2 x3 is the features, x1 x2 x3 x4, these are the independent variable. Some call them as your dimensions, different dimensions. So suppose I have 4 column, that means what, my data is a 4-dimensional data set, dimensions, each column dimensions. Okay, and this, few call them as vectors, containing different component called x1 x2, vector component called x1 x2 x3, like this they will call in machine learning. Okay, now to our context naive base, when we define this x1 x2 or whatever we have xn, when these dimensions, these features, these input variables are independent to each other. Okay, when these features are independent to each other, that is like, this is not the usual case every time, there may be some dependency on each feature. Okay, one feature is dependent to another feature in real life scenario, but when we assume they are independent and we started implementing Bayes classification algorithm, that is called naive Bayes. That means the input features, the independent variables, are not dependent with each other. This we should tell in the beginning, that then only we can apply this naive Bayes classification algorithm. So the answer to the question is, why Bayes theorem is so naive? You have to say what? The input features are independent to each other, that's why it is naive. Again, there is no dependency on one another. You have to assume that initially, then only you can apply naive Bayes. But in real life scenario, this is not the case. There should be some dependency that you need to identify. Making sense, right? So today less people joined, is it? Why? Is it a holiday?
No.
Oh, Dinesh, yeah. Please tell me what doubt you have.
Yeah. Actually, like, can you please, correlate all this once again? Because, like, I can understand that conditional probability. So, in
Mhm.
conditional probability, we were using that, and that is totally fine. And then the
Hmm.
Bayes theorem and naive Bayes theorem was there, right? So,
Bayes
what is?
theorem, Bayes theorem we have seen yesterday, right? This is the
Yeah,
same.
yeah. That is also fine. Like, I've also gone through some other videos and the
Hmm.
examples. Like, I've got some
Hmm.
ideas about it, but still, as you said, I need to spend more time on it. So, like, what
Naive
is
Bayes.
naive Bayes? Like, Bayes and naive Bayes. Like, you said, there is a independency. Like, there is no
So
dependency
you do
on
one
each
thing.
other.
You summarize what I just said, and I'll rectify you in between if you tell something different. Like where what
Okay.
I said in terms of
Uh-huh.
independent variable.
Okay. So naive Bayes theorem, which will actually, classifies based on the Bayes theorem. So, like, in here itself, I have a catch. Like, it's classifying the outputs, or classifying the what do we call that, events, right? 1 minute. Yeah.
So
Classifying the events.
did you got the part when I say classification problem and regression problem?
Yeah, classification means it's classifying based on some conditions, and the regression only have a confusion.
Okay. No worries, no worries, no worries. So not based on the conditions. So
Mm-hmm.
what happened in machine learning? It, this is a machine learning
Mm-hmm.
algorithm, okay? ML algorithm. I'm writing
Okay.
MLA.
Mm-hmm.
Okay. Here you need to provide some data, historical data
Okay.
specifically.
Okay.
That's why it is called supervised learning. This is called
Okay.
what? Supervised learning. So supervised learning means what? You have the historical data and your classification data also known. What does that
Okay.
mean? That means you have the data and you know whether it is spam or not. So that's why it is called supervised data.
Okay, so
Now,
supervised means like classification is kind of spam and not spam. Like it is a valid or non-valid.
correct.
Okay.
Classifying. You're classifying to one category.
Okay.
So what masla, how this is, okay, let me explain you detail, guys. So how this works actually. Consider our this spam no spam case, okay? So you have a mail, okay, you have mail, and there is something written in the mail. I'm writing the mail as like this, okay? A few words
Okay.
are here, few words are here, few words are here. So now this mail is one data point, okay? And
Okay.
you have also this result with you whether this mail is spam or not spam. Suppose this is spam. So this data you have already. This is the
Okay.
historical data that you have, one mail data, which you divided into a data frame, which data frame contain how many columns? 1, 2, 3, 4, 5, 6, 7. 7 columns. The 7
Okay.
columns data. So this data is mail data.
Okay.
And you
So which
know
means
this.
like, sorry to cut you off, like which means I have a data that is a classified data, and like sorry, I have a
Correct, correct.
data which is a historical data, and also it is a classified kind of data.
Labeled.
Okay.
So
Okay.
this whole set is called labeled data.
Okay.
Why this is labeled data? Because you have the label here. This is what you are going to predict in
Yeah,
future,
spam or not spam. Okay.
spam or not spam, but using the historic data. Now this is called a labeled data or supervised data. Why supervised? Because we know the outcome here. We already
Okay.
know based on the. So this is called classification problem. And how this works? Now suppose you have, this is one data point. Like this I have 1,000 data points like this, right? Like here second data, this is first data point, second data point, like this 7 columns, and it will say spam or not spam. Suppose this is not spam.
Not spam. Okay.
Like this you have thousands of data, right?
Mm-hmm.
Data points. So what you will going to do in machine learning, you will pass this data to the machine learning algorithm model,
Algorithm.
ML
Okay.
model. Okay, you will pass this data to here.
Okay.
How you are going to pass? This is all about the courses, okay?
Okay.
Once you complete the course, you will get a clear understanding how this is working and what is this
Okay.
algorithm and all. Okay, now here if you see, based on this data, the mail data and their outcome, machine will try to understand the pattern here, so that next time, so using this data you will train the machine, and machine will see the text data, the outcome, and it will try to learn from it. Okay, that's why it is called machine learning. Machine is learning these details and their outcome.
Okay. So
But
in machine learning, we'll have an automated algorithm, or we supposed to write an algorithm for
that you are going to sell, there is a
okay.
bunch of list of algorithms that, like, there's, again, that is like, that's why the course is all about, you have last
Okay.
4-5 modules based on this only, which model to use, when to use which model, how the what is the mathematics behind the machine learning model. Okay, so those things are there in your
Okay.
upcoming session. Okay, now
Sure.
this is called classification problem. Okay, now what is the end product of this? Once the training is done, machine trained properly, so you are going to deploy this machine in your work environment. What will that do? What that will do? When any new mail will come, okay, now the machine will predict it is spam or not spam. Okay, so once the training is done, you will keep this machine in your work environment, so that any new mail will come, you will put that into the machine, and the machine will start saying that this is spam or not spam based on the historic data it got trained from.
Okay.
Okay, so this is called classification.
Okay. So giving a classified and like
Data,
historical
correct,
data, that is our job to do.
correct.
Okay.
That is the fuel of this field, data. Whether label
Okay.
data, non-label data, raw data, anything. Data is the fuel, and this is the
Okay.
new power here. Money is not now the new power. So those company who hold the data, so why
Mhm.
Google and Chat GPT, OpenAI, they are so much? Because they have the data, enormous amount of
Yes.
data. They can do anything from their data, even if they are
Okay.
not sure what to do. So this data gathering is the first thing.
Okay.
This you
But
need to have.
correct me if I'm wrong. So like naive Bayes theorem will only work with the classified data. Like I mean,
Correct,
labeled or a supervised data.
correct,
It won't
correct,
work with non-supervised.
correct. So
But Bayes theorem
non-supervised.
will work
Hmm.
with a non-labeled or a
No,
non-supervised data,
no,
right?
based, that is a mathematical theorem. Here, this is a algorithm that we are using,
Okay,
naive
okay,
Bayes.
okay, okay.
Okay.
Sure,
So
sure,
that
sure, sure.
is, so based on the mathematical formula Bayes theorem, you are creating an algorithm called naive Bayes theorem, or naive Bayes algorithm, you can say. Okay. And the thing is here, why it is the answer to the question why it is called naive, because here I say, right, this data point has 7 columns, suppose 7 columns. You have to assume, or you have to say in the beginning, that no column is dependent to each other, then only
Okay.
it will be naive. Okay. Although in real life scenario, so that means whenever you are going to use naive Bayes classification algorithm, not any other algorithm, I'm saying particularly this what naive Bayes classification algorithm, there you have to assume these are independent to each other. And how this is working here, if you see the formula, this formula is familiar, right? A by B, A pi B, right? So here we are calculating what? Probability of Y. So here Y is this part, spam or not spam. And X is combination of what? X1, X2, X3, X4, or whatever column we have. That means you have this historic data. Based on this historic data, you are predicting what? A probability of spam or not spam. Getting it right?
Yeah, yeah.
Okay. No worries, guys. It is like very interesting. You are going to get going forward, because if you are interested really to know machine learning, no, you are going to enjoy it. Very good thinking actually. Now this is all about that we a quick recap. Now let's see few of the terminologies that you are going to encounter now onwards. That is called your random variable. So random variable, PMF, and CDF. Three things. Random variable, PMF, is the probability mass function. CDF is the cumulative distribution function. We'll see. Okay. So random variable is simple. You know this. Maybe you are not getting right now, but you know this. What is this? This means, suppose you are, what happened? Suppose you are rolling that dice, right? So here one particular value will come between 1 to 6. Now those values range are from what? 1 to 6. Now those values are called random variable. That means here, if I roll a dice, I can say random variable in this scenario ranges from 1 to 6. That is means, what is the random variable? The outcome. Did you get what I'm saying? Like when you roll a
So
dice.
like random
Hmm.
variable means like will have, like if we were going to work on something, we're going to have an idea about like, okay, it's going to give me an outcome between A to D. So
Correct.
between A to D,
Hmm.
I'm going to get an outcome. So that is called random variable, right?
Yeah, because that is a variable which is taking some range of values, and in our particular case, what? 1 to 6.
Okay.
So the event or the outcome it is getting. Give me 1 minute. I switched off the fan. This is too hot here. Let me switch on this. Yeah. So if I'll open the window, the winds are disturbing us. If I'll switch on the fan, that sound also disturbing us. So one
Happens.
second. So let me switch on the AC. So that, okay. Now probability mass function. Now to understand this, we need to use random variable. That's why we say what is random variable. Now what is probability mass function? A probability mass function, PMF, is a function that describes the probability of a discrete random variable taking on a certain value. For example, if random variable in the dice game is the number of points rolled, the PMF, probability mass function, would be the probability of rolling a 1 or a 2 or a 3. And how we are going to write it? F of x, probability mass function f of x is equal to probability of random variable. So capital X is here the random variable and x is the value that is going to take. This is how it is written. So what is capital X here? This is the random variable. What is small x? This is the value that is going to take. Suppose you are rolling a dice, whether x equal to 1, that means what? You are calculating when the dice 1 number will come. X equal to 3 means what? On the dice, it will 3 will come. So the random variable at some specific value. This is how you define
So
probability mass
the
function.
random variable will be 1 to 6, right? So we'll take in random variable from 1 to 6. We can take 3, 4, 5, or 6, whatever.
Any particular value, correct? Any
Okay.
particular value, if you write like this, that is that the probability mass function at that particular point at x equal to 1 or
Then
x
what
equal to
will
2.
be the, then what will be the number we put have in capital X?
So capital X is the this is how you need to write. Capital X is the random variable denotation, like how you need to write random variable. So this capital X means what? A random variable. Small x is the specific value of that random variable. For example, okay,
Yes, sir, that the random variable capital X, we need, do we need to assign the value from 1 to 6 or not? That total value is 6.
not total value is
1 to
not 6. Yeah, total value is ranging from 1 to 6.
Range 1 to 6. In that capital variable, do we need to give the total range value or what
Specific value?
value?
Specific value.
That is,
So
I'm asking what if you give the example means it will be clear.
so the below is the example. Don't worry. Below is there is the example to make you understand
Ashish,
this.
x is the random variable and small x is what? To take a note.
Uh, Anything between 1 to 6. Any
No,
number between 1 to 6.
Random variable I can get it. Like that random variable I'm clear. Like in this formula was out there, right? F of x. The capital X is denoting random variable, and the small x you said one term, right? Denoting
Any number between 1 to 6.
Okay,
Small
so
x, you can write any number between 1 to 6. That means what?
okay.
You are calculating the probability of getting. So if I make small x equal to 2, suppose here,
Okay.
I write probability of capital X equal to 2. What does that mean? That I am calculating for the random variable x, which is taking the value 2.
Okay.
That means what? I am calculating the probability of getting a 2.
Okay.
So if I'll make this to 3, what does that mean? I'm calculating the probability of getting a 3. If x, capital X equal to 6, what does that mean? P of capital X equal to 6.
6, yeah.
That means what? That means we are calculating the probability when the random variable will take the value equal to 6.
Okay, so
What
this
is
is
the
a random
probability now?
variable. Okay.
So what is the probability of getting a 6 in a dice?
Like when you're saying once, right?
Probability of getting 6 if I roll a dice.
1 by 6.
1 by 6, right? Because probability of getting 6 is the sample space is 6 and getting 6, the probability is of 1 times, right?
Yeah, event. Yeah. One time event.
event. So 1 by 6. That
Mhm.
means like, so with another example, let's try to
Okay.
understand with another example. A coin is tossed 2 times, okay? And you need to calculate what? The coin is tossed 2 times. If X is the number of heads here. Now, if you see here, what is capital X here? Random variable. So I am saying if capital X, that means my random variable is the number of heads. Try to distinguish the difference here. Here I am defining my random variable is the number of heads. Here what I am defining the random variable?
Rolling a dice.
Okay, rolling a dice, but what is the outcome of that event, of that action? Getting a number.
Yeah.
So here in this context, my random variable is what? So it is as per you, you have to define what is your capital X. And based on that, so if you here I define my capital X as what? Getting a number if I roll a dice. But in the second example, what I'm defining my capital X is getting the number of heads. Try to see this difference here. Now, in the second example, my random variable is nothing but number of heads when I toss a coin 2 times. Then write me the probability mass function for this operation. Since the coins is tossed 2 times, what is the sample space? This is the sample space. Everyone agree? Either head will come, head tail will come, tail head will come, tail will come, right?
Yes.
Now when I say my random variable is the number of heads, that means in the upper case it was ranging from 1 to 6. In the second example it ranges from, try to think.
1 to 4.
Okay, nice try, but still not. So when I say number of heads, this is my sample space. Can you see how many heads
1
are
to
there?
3.
Right. So 0 first, this is 0 head. These two are 1 head. This is 2 head. So that means what? 0 to 2. That is the range of your random variable.
How come there is a 4 heads, right? However.
No, I said 0, 1, 2. That is the range. So here in the first example, X range is from 1 to 6. In the second example, X range is from 0 to 2. 0, 1, 2.
Yeah, that's what I'm asking. Like why it is, stopping till 2. Like we have 1, 2, 3, 4, 4 heads, right? And also we
So,
were tossing two times.
so 2 coins, right? So this is the overall outcome of tossing 2 coins, isn't it?
Yeah.
Can you see anywhere 4 heads is there? Because we are tossing 2 coins, right?
Okay, so I assume that there is a 2 heads, right? So that is also count like that.
So so this is 1 coin, this is 1 coin. This is the outcome of 1 coin, this is the outcome of another coin. So if we'll toss 2 coin, either head in 2 times, not 2 coins, 2 times. Single coin 2 times. So what is the all possible outcomes? Every time either both head will come in the 2 times if we'll try, or either first trial head will come, second trial tail will come, or either first trial tail will come, second trial head will come, or tail will come in the first trial, tail will come in the second trial.
Yeah.
Apart from this, any other combination possible?
No.
So if X is the number of heads here, in each trial, in each pair of outcome that we're getting, what is the range of getting number of heads?
Okay, so even if we got 2 heads also, we're supposed to consider as 1.
No, you didn't hear my question.
Okay.
If X is the number of heads I'm telling here, okay, then what is the range of X in my all possible outcomes? number of heads is X. How many heads we are getting in the first trial?
2.
2. So
Yeah.
X possible one value is 2, right?
Okay. Okay.
Number of heads. So if X is my number of head, in the first trial, how many heads are coming? 2.
2.
So here X value can take up to 2.
Yeah.
Agree?
Yeah. Yeah.
Now consider this second trial where one
1.
head will come, one tail
Yeah.
will come.
Yeah.
Now here X is what?
1.
1, right? In the
Yeah.
third trial, what is X?
1.
1. In the fourth trial, what is X?
0. Okay. 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 Now only I'm getting it. Like I was literally counting, like, I'm counting like in primary school guy, like 1, 2, 3, 4. There is a 4x, but we are writing 2x like that.
Okay. So
Okay,
that means what?
get it.
Here X value is ranging from what? For this one it is 2, for this 2 it is 1, for this one it is 0.
Okay,
So
so
X
X is the
value
number
here,
of hits. Okay, okay.
number of heads. X is the number of heads. Here what is X? Here in the first example, X is the outcome of
Yeah.
rolling a dice. So that outcome varies from 1 to 6. Here X is what? Number of heads.
Okay.
So every trial.
So there we can take a random number, like in the dice thing, we can take a random number, but in here we have a range between like 0 to 2.
No,
Sorry,
that is
0.
also
Yeah, 0 to
range, right? In the dice
yeah,
also there is
1
a
to
range
6.
between
Yeah.
what? 1 to 6. Here what is the range? 0 to 2.
2. Yeah.
0, 1, 2. Right? So
Okay.
now you got a clear understanding what is probability mass function
Yeah,
in
yeah.
terms of random variable. Now how to write it? This is how you need to write it, how you wrote here, right? So probability of X, X means what? Number of heads. So that means you are calculating when I'll get 0 number of heads for the same experimentation. That is the probability of getting X equal to 0. That means 0 head. Where
Yeah.
what is the scenario when you will get 0 head? Which one in the sample space?
Tail.
Tail, right? So probability is what? The event divided by total sample space, right? So how many event possible? X equal to 0, 1. That's why 1 divided by 4. Okay, this one. You can see 1 divided by 4. Now what does that mean? What does that mean? Like when X equal to 0, that means head count is 0. How many possible outcome for that? 1. 1 by 4. So this is clear. This is clear. Now when probability of X equal to 1, what does that mean? When only one head will come.
Yeah.
How many event possible for that?
2 events.
2. So probability is 2 divided by 4. Making sense?
Yes.
When X equal to 2, how many events are possible? This single one.
Yes.
So their probability also what? 1 divided by 4. All clear? Okay. Now this is probability mass function, PMF. Okay. What is CDF? Cumulative distribution function. What is CDF? So cumulative distribution function is a function that describes the, let me scroll down a bit. Cumulative distribution is a function that describes the probability that a random variable is less than or equal to certain value. So in the PMF, what we say? X equal to something. Here what we will say? X less than equal to something. And why we are saying this? Because it is not calculating at a particular value rather than cumulative value. That means at X. So when I say, let's see how we are denoting it. Okay. See, this is how we denote it. Less than random variable less than equal to 1. What does that mean? Equal to 1 and prior to this value. So for example, what I can say, consider X represents outcome of rolling a 6-sided die. Now here possible values of X are 1 to 6. We saw this. Now what is the CDF of this function? This means you have to calculate at X equal to 1, not at X equal to 1, at X less than equal to 1. But this number starts from what? 1, right? So nothing is prior to this 1. So that's why the probability of x less than equal to 1 is 1 by 6, because nothing less than 1, because x starts from 1 only. When we say f x less than equal to 2, that means what? At x equal to 1 and x equal to 2. When I say x less than equal to 3, that means what? At x equal to 1 plus at x equal to 2 plus at x equal to 3. So if you see, if I am calculating at this point, I am doing a cumulative addition of the prior values at x less than equal to 3. When I say x less than equal to 4, what does that mean? Probability at 1, probability at 2, probability at 3. So we are cumulating its value and its prior values as well. That's why it is called cumulative distribution. So what is the main difference between this and the above one, PMF? There we are calculating at a particular value, but here we are considering that value and the prior values also. Now can you tell me, if I'll do like this, what is the probability of x less than equal to 6?
6 by
If
6.
1, right? 6 by
correct,
6.
6 by 6. So that means at the last value of the range of your random variable, always you will get the, because these are the probability of at 1 then plus 2. So at the end, if you sum all the probabilities, what is the value? Probability value 1, right? So the CDF of a random variable is a function that gives the probability that the random variable is less than or equal to a given value. It is used to describe the probability distribution of a random variable. And in general, this is written as what? X less than equal to. So whenever you see less than equal to, you understand this is what? We are calculating the cumulative probabilities.
So
At
one
that
means the
value,
first, sorry, yes, the first one is for like for a fixed, a particular value. This one is for a range of values like that, no?
there at that value and other values of that random variable prior to the other
Okay,
value.
okay.
So that means if you are calculating for 5, it will include 1 also, 2 also, 3 also, 4 also, 5, right?
Okay.
This is cumulation we are doing. That's why it is called what? Cumulative distribution function. We are
Okay.
calculating the cumulative probability of at that particular point also prior to that value.
Okay.
Okay. So this is all about your PMF and CDF. So these are, we left out from previous session, guys. Okay. So today's session, actually, it will be another. So I told 2 sessions for this, right? Probability and statistics. Now these are very important in your machine learning. If you're going to build a machine learning algorithm or model, so these things are also basic thing that you need to know. You need to understand about your data. Now when I say data, suppose you collect height of people of one city. What kind of data that is? Is it a categorical data or any what numerical data or continuous data? What type of data is that? If I'll collect the height of people of one particular city.
Categorical
So
data.
so when I say categorical, height is like, suppose I am calculating a height 5 feet 5 inch, right? That is not a category, that's a number, isn't it? Okay,
Yes.
so this type of data, which are numbers, continuous numbers, 5.5, 5.6 inch, 5.7 inch, weight of people, okay, stock price values, those are numbers, a continuous numbers. If I have that kind of data, that is your what? Continuous type of data. But when the data is not continuous, that means consider this a rolling a dice. Here I can't say if I roll a dice 2.3 will come or 4.2 will come. No, right? Either these are discrete data. 1 will come or 2 will come, 3 will come. So these are fixed. So the data is not continuous. So you have to understand the difference between discrete data and continuous data here. So if I collect the rolling number of a dice, that is my discrete data, because that values are a whole number, either 1 or 2 or 3 or 4. You can't say 2.3 will come, right? But when there is point or continuous data like height, weight, wealth, okay, stock price, so those are what? Continuous data. You can say my height is 5.3, his height is 5.4, 5.7, like that. So there is no breaking point here. It is continuous. But when you roll a dice, the data is discrete. 1, the next number will be 2. No number in between 1 and 2. You can't say 1.5 will come. Are you getting the difference here of discrete and continuous?
Yes.
Okay. Now we'll go one by one. First, we'll cover discrete distribution and their properties. And so what is our aim here? I'll tell you. We are going to understand few of the known distribution. Known distribution means for discrete distribution, there are certain known distribution. And using that known distribution, you have to implement your data, or you have to check your data. Suppose in the office, you have given some data and you want to know which type of distribution it is following, or you are not aware about your data. So you have to do some analysis to know about your data. So to know about your data, you have to follow these properties of this distribution, which you are going to see right now. Bernoulli distribution, binomial distribution. You are trying to understand this distribution, and once you have some unknown data from your office, you correlate with this kind of distribution and try to find out which particular distribution it is following. That is the aim here as a data scientist guy. So the job is actually not so easy. Like maybe, so many things you have to do. Okay, so many from so many angles you have to consider. Then only you can conclude something. This is called data driven decision. So we are going to apply statistics, mathematics, coding, everything to our data, and finally we'll get some outcome. Okay, now let's try to understand different type of distribution here. Discrete distribution.
Ashish, like this is not about the thing we were saying. Like when we were going into an organization, like if we were into a project, like we have to create a machine learning or deep learning AI or whatever. So on that time, a team, a group of guys will work on one project, right? So I supposed to work on one like, for example, I'm working on a module 1 and you're working on module 2 and someone was working on module 3, then this all will be correlated, right?
Yes, but that is not what I'm saying about projects. I'm saying about in the project you have, suppose consider one project where your job is to find, classifying the mail as spam or not.
Okay.
Okay, that is your job in your one project, and you have been given some data and you are not sure about that data. Or suppose, for example, your job is to create one model which will predict upcoming stock prices.
Okay.
Based on some historical data. So now you don't know about your data, which type of distribution it is following. So if what I'm saying by distribution, imagine it, you are going to plot your data, how that data looks like. If you'll plot your data, and we'll see with coding examples how to plot your data also, we'll see. So if you'll plot your data, it may looks like a heel, it looks like something random zigzag position. So that is actually your distribution pattern of your data. And as a data scientist, you have to understand this distribution pattern, which type of distribution it is following. You have been given the data. Your job is to create a model which will predict stock price. But unless you know about your data, you can't conclude that anything. Or you, like, it is even if you directly put that data into machine learning model, it is not sure that you will get the required outcome. So before training or modeling anything, you have to understand your data first. If I'll plot this, how does this looks like? Anything familiar that I already know, that means what? This type of known distribution we're now going to cover. anything from this type of distribution following? Let me remember. Okay, it is following a continuous distribution. So my data which has been provided to me to do this project is following a continuous distribution. That is your job, to identify first, know
Okay.
about your data. So that's why we are learning this distribution,
Okay.
so that in, yeah, now you conclude.
So once if we know that, then we can uh, start to work on it.
Correct. And you will get some overall idea, because initially you don't have any idea. You have been just provided the data and tell, like, create one model to predict the stock price. But unless you know your data, what analogy or what analysis you are going to derive from that, and if you directly put also, that is not going to work. You have to understand the data first.
Okay, so with that only we can able to modify or do some perform.
Yeah, or you can take some decisions. Okay, this is my data, this is the mean value, then I will try to collect more data from this region or that region, like those kind of thing. And for example,
Okay, okay, get it.
Okay, so that's why
Totally.
we are going to understand few of the known distributions, so that in case in future you will get any unknown data, you will try to correlate with any one of this distribution. And so we'll see what this distribution and its properties. So once you identify, okay, my data is following Bernoulli distribution, then whatever you learning about Bernoulli distribution, you can directly apply to those data, isn't it? Okay, so let me try. So to be honest with you guys, these discrete distributions are not real life example. Always in real life example, you will get continuous kind of data. Are you getting what continuous type of data? That point, like,
Yeah,
height,
0.1,
weight.
0.2, 0.3. Yeah.
Yeah, but as we are covering, we'll see the discrete distribution first, then continuous. But yeah, but this is also fun, because these are the theoretical questions you can expect from any company if you're going for any interview. Okay, what is Bernoulli distribution? What is the mathematical formula of Bernoulli distribution? In which situation you are considering Bernoulli distribution? Okay, we're going to see this. Now first understand what is Bernoulli distribution, and this is specific to what? Discrete data, not continuous. Okay. Now, the Bernoulli distribution is a discrete probability distribution that models the outcome of a single binary event. What does that binary event? That means it has two outcomes. Can I consider the rolling of dice as a binary event?
No.
So binary events means what? Two outcomes, true or false, either this or this. When this type of models or distribution you encounter, that there you can apply Bernoulli distribution. So what first condition is what? The event should be binary, such as toss of a coin or outcome of a yes or no type questions. Two things, positive, negative, or false or true. For example, imagine that you are running a small business and you want to determine the likelihood that a customer will make a purchase. So here, what is the binary outcome? Either purchase or no purchase. So here you can apply Bernoulli distribution, because here the event is binary kind of event, and the outcome is either customer is going to purchase something or the customer is not going to purchase. So this is success criteria. This is your failure criteria. So to understand this, what you need to do again? You might need to collect the data of number of customers who visited the store and the number of those customers who make a purchase. You have to collect their data, and based on this data, you could then estimate the probability of a customer which is going to purchase or not purchase. Okay. Now, like for example, you might use Bernoulli distribution to determine the probability that exactly 2 out of 10 customer will make a purchase based on the historic data. Now we have some integration with Bernoulli distribution here, which is called binary distribution. So here only difference is the event you are going to try once. So suppose you toss a coin, you will do it once, and that outcome is what? Either head or tail. So the event, when the event will happen only once and the outcome is a binary outcome, that is there you can say I can use Bernoulli distribution. But consider the same situation, same coin situation, but instead of trying once, I will try multiple times, more than one times. And then I will calculate how many, what is the probability of getting 3 heads? What is the probability of getting 4 tails? So when I say probability of getting 4 tails, that means what? I am trying more than once. For the single binary event, I am trying more than once. Now, when you do this multiple time trying, that distribution, that data, when you collected those data after trying multiple times, and you are going to answer few questions based on that, so there you can use binomial distribution. So what is the basic difference between Bernoulli and binomial? Here this is single trial. Here this is what? Same binary event. Same binary event. If you see, the binomial distribution is a probability distribution that represents the number of successes in a series of n independent yes or no type of experiment. So first condition for binomial distribution, it should be binary event. Second condition is you have to trial it multiple times. What is the third condition here? You have to define a success criteria. That means whether getting a head is success for you or getting a tail is success for you. That you need to define first. Now I have proper example for this one, a farmer example here to make you understand. Now before jump into the example, this is the mathematical representation of binomial distribution. Okay, here I think I need some of your mathematical knowledge.
Ashish, and also like you said there is a difference, right? So the Bernoulli yeah, right.
Bernoulli
That
distribution.
Bernoulli distribution will happen only once, right?
Huh. But binary event, same in both the distribution, binary event. That means what? 2 outcomes. But in binomial distribution, you are trying it more than one times and then trying to predict something. Like how many times, what is the probability that I'll get 4 heads if I'll try it 6 times? If I try it 10 times, suppose I'm flipping the coin 10 times. 10 times I flip the coin and I noted down the data. Head, tail, head, tail. How many times head will come? How many times? Every trial I am noting down the data, and the end, what I am calculating? The probability of getting 5 heads.
Okay, so
How to calculate the probability?
okay.
Here.
So binomial, we were trying multiple times with the binary data, but in Bernoulli, we'll try only once with the binary data.
Once.
Okay,
Correct.
okay.
So that is the basic difference.
Okay.
But here, when I say, tell me if I toss the coin 10 times, tell me what is the probability that I'll get 5 times head? How you are going to calculate?
We have to write.
Okay, we have to flip the coin. Now,
Yeah.
if I'll make that to 1,000 times, then you are not going to perform the task, right? And you'll start scolding me. Why you're not going to try 1,000 times and flip the coin and write the data? So to avoid this kind of thing, you have this mathematical formula of binomial distribution. Now, by doing it 1,000 times, by flipping the coin 1,000 times, and as we know the coins has 2 outcomes, we already know this way is going to follow what? A binomial distribution. We understood from this in the first sentence. Someone gave me the task, tell me how many times I'll get 25 8s if I'll try 100 times. So I thought in my mind, okay, this is a binary event and we are doing it multiple times. So this data will follow which distribution? Binomial distribution. From there you identify. And you apply that in this formula, so that you need not to write down the outcomes and save it somewhere, then you calculate the probability. Instead of that, you put all the what you have information in this formula, and this formula will tell you the probability of getting exactly 25 heads if you are trying 100 times. And even if someone will ask you, 1,000, a million times also, you can use this formula and answer the question. Now let's try to understand this formula, because that is important. Now I need your few of your mathematical understanding here. Here, probability of x. So x means what? The independent variable. That means I am calculating the getting 25 times of heads, the probability of something. What is n? So this is nothing but this is called NCX. Have you seen this terms previously? So NCR, like that. This is a mathematical representation of what? This is coming from the topic called permutation and combination.
Yeah.
Okay. So NCR means what? NCR means n factorial divided by r factorial into n minus r factorial. This is the formula of NCR. That means out of n possible things, you are choosing r things. In how many ways that is possible? How many ways the combination is possible? This is the answer. Now what is factorial? When I say 5 factorial, what does that mean? So guys, have you heard about factorial previously?
Yeah. 5 into 4 into 3 into 2 into 1.
Correct. 5 into 4 into 3, like this. So this is the nothing but that factorial only. So this is the formula. When I say NCX, what does that mean? N factorial divided by x factorial into n minus x factorial. Okay, this is the formula. This is NCR. What is this one? This. So here I have already mentioned, here n means, n in this formula, number of trials. That means in our example, what I give 100 times. 100 times you have to flip the coin. That is the n, total number of trials. X is the number of success. So as I told you, in this third point is what? You have to define your success criteria. Getting a head is success. That means getting a tail is failure. So X is the number of success. That means what? In our case, I asked you how many times, what is the probability that I will get 25 heads. That means what? My success criteria, I defined head as success. That means what? X is the number of success. That means X is 25. 25 times I need to get I want to calculate for X equal to 25. What does that mean? I want to calculate the probability of getting 25 times head out of 100 trials. So X is the number of success. What is P? P is the probability of success. What is the success criteria in our particular example? Head. What is the probability of getting a head? Probability of getting a head is 0.5.
Yeah.
Or 1/2. Agree?
Yes, sir.
So P is the probability of success on a single trial. Now tell me what I need to, what answer I'll get if I'll put everything. So my question is what? Tell me the probability of getting 25 heads out of 100 trials. Tell me what should I write here in this equation? Probability of
P
X
of 25
is equal to, correct, P of 25. Okay, equal to NCX. What is N here?
100.
100 C. X is 25. P is probability of success. That means probability of getting
0.5.
0.5 to the power X is 25. 1 minus P is 1 minus 0.5.
Yeah.
To the power N is 100 minus 25.
Minus 25.
So whatever will be the answer here, that is your final answer of what? Probability of getting 25 heads if you'll try 100 times.
So I have to do factorial for 100 and then
correct. 100 factorial, then 25 factorial into 75 factorial. This is the value for this part. Okay. Into 0.5 to the power 25 into 0.5 to the power 75. this whatever answer you are going to get, that is the answer of probability score according to
Okay.
which distribution? Binomial distribution. Now I have one example for you. Now you tell me this answer. I already actually I showed you the question and answer. So see, for example, I try to make it a bit funny. I'm not sure whether it is funny or not, but you are a farmer, okay, and your job is to incubate eggs, okay,
Mm-hmm.
and while incubate eggs, you have two possible events here: a female chicken and a male chicken. So is it can I say, is it a binary event now?
Yeah.
So either get this female chicken or male chicken. This is it. And why I want to know using the binomial formula, I should not have told you the answer. Tell me what is the probability of getting exactly 5 female chickens? And here, what is the success criteria?
0.510.
What is the success criteria? Not the
5.
probability,
Okay.
success
5.
criteria. So here in our head tail wala example, what we did? Getting a head is my success criteria.
Okay.
Here, what is my success criteria? Getting a
Female chicken.
Female chick 5.
5.
okay
Yeah.
female chicken. That is my success criteria, and
Yeah.
I want to be successful how many times? 5
5
times.
times.
Now you have to tell me what is the probability of getting exactly 5 female chicken, and how to implement this in a formula. So this is our formula. Okay, let me scroll down. I always struggles when I use this e-writer. Okay, to use the formula to calculate the probability of getting exactly 5 female chicken, we can put x equal to 5. Agree? 5 times successful. Total times I'm trying 10 times. Out of 10 times, what is the probability?
Where the 10 times was like in the previous
It's
example,
not
100 was
mentioned
given.
here.
Where?
Like it was also given to you 10. Okay.
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 I
Let's
forgot to
assume.
mention
Okay.
in the
Okay.
example. Yeah. So n equal
Okay.
to, let's suppose you are trying 10 times. And how many times? Then so to the probability you are calculating here, what is the probability of getting exactly 5 female chicken if I'll try to incubate 10 eggs? Now you got the answer here. 10C5. 10 times you are trying and 5 times you are going to be successful. Probability of getting a female chicken 0.5, right? Probability of getting a male or female, that is the same thing as head and tail, right? Probability is, if I'll
0.5.
incubate a 1 egg, 0.5 is the score if I'll go for a female chicken. And as per the formula, 1 minus p, again 1 minus 0.5 to the power x minus n, sorry, n minus x. N is 10, x is 5. So here, if you will solve this problem, this is 252. What is, should I calculate this one? This is going to be 252. How to easiest way to do this? 10 factorial into 5 factorial into 5 factorial, right? So this I can write 10 into 9 into 8 into 7 into 6 into 5 factorial. So I'm not writing 5 into 4 into 3, like instead of that 5 factorial. Why I'm writing this? Because I will cancel one of the 5 factorial here. So what is left?
Yes.
10 into 9
10
into 8
into 8
into
into
7
7
into
into
6
6.
divided by 5 factorial.
Yeah.
This is nothing but 5 into 4 into 3
Equal to
into
3
2
into 2
into
into 1.
1. So here I think some of will cancel, right?
Yeah,
So
4.
this will cancel. 3 into 2 into 6 will cancel. 4 will be cancelled by, this will be 2.
Yeah, 2.
Right?
5.
10, 2. Yeah.
Right? 2 into 9 into 2 into 7.
Yeah.
6.
Correct, right? 252.
Yes.
Correct, right, guys? 18 into
Yes.
14. Okay. So
Yes.
this is how you need to calculate.
Okay.
And I think this, so if you calculate like this, what is you are getting? 0.207. That means
Yes.
there is 21% chance that if we'll try to incubate 10 eggs, out of them 5 will be female chicken.
And then what is that probability of getting at least 7 female chick?
So that is the question. That is to you only. Okay, to you people only. Tell me how to calculate
Okay,
the
okay,
second question.
okay. So that's our question. Okay, instead of 5, we supposed to change 7. That's it.
No, if that would be simple, then I should have not asked it, right?
Okay, okay. So probability of
Only you
getting 7
replace.
female chicken.
So here the catch is at least.
At least,
You are
okay.
saying at least 7. Here in the first question, you are saying exactly 5. Okay, but here what you are saying, your x is not 7 here. Your x is what? Where is my pen? Okay, if you see here, x is what? X is less than, sorry, greater than equal to 7. That means what? X can be 7, x can be 8, at least. X can be 9, x can be 10. Because 10 times you are trying, right?
Yeah, at least get it.
So that means what? You have to do all this calculation for each value of x.
7, 8, 9, 10.
Okay, then you give the score, at least 7. Did you get the difference here? What is the catch here? Just this exactly 5 and at least 7 is different here. At least means I should calculate this formula with x equal to 7 also, 8 also, 9, because this also at least 7, all this 8, 9, 10 also.
So we'll get a 4 different values or 8.
Correct. And the summation of that would be your final answer.
Okay.
So either x equal to 7 or x equal to 8. Why I'm saying or? Do you mean what I need to do? Add the probability, right? Probability of when 7 times you are successful plus probability when 8 times you are successful. Probability of 9 times you are successful, right? And if you want to calculate the overall probability, then probability of this plus. So using x equal to 7, 8, you will get, using x equal to 7, you will get something like this number. Using 8 also, you will get something like this number, isn't it?
Yeah.
And at the last, you say, what is the total probability of getting at least 7 female chicken? Okay, guys. Now,
So like
this,
here, the value of P will always be 0.5, right? Or half.
here, because this
It is
depends on
binary, right?
the binary event, but depends on your experimentation. Because we know, if I consider a unfair coin or unfair event, when I say unfair event means what? There is a possibility that the events are not equal. That means I say I have a unfair coin which will tell me 75 times it will come head, 30% times it will come tail, because that is unfair coin. How to make an unfair coin? You scratch any of one of the side and try to reduce one of the weight. Then what will happen? That part will always at the top, because the heavier part which you have not scratched. Are you getting what I'm saying here? How to make an unfair coin? So you can ask me like what is unfair coin? So if I toss a coin and 0.5 is head, 0.5 is tail, that is fair coin. But if I do some scratching or try to reduce the weight of one side, then that is a unfair coin. That means what? The side which is not scratched, that will always at the bottom. So the possibility of getting a head will be less here. That is an unfair coin. That time what? That time if you know head will come 70 times, 70% time, tail will come 30% time. That time what you need to use using head? 0.7 instead of 0.5. So again, so these are specific to the experimentation that you used. So here everything is fair in our case. Getting female also 0.5, getting male also 0.5. Now what is geometric distribution? Now here is certain thing you need to understand. Same thing, same concept, but here You are not calculating the total number of success. Here you are calculating the probability of getting first success. That means what? I have 10 times I'm trying to incubate the eggs. Sorry, 10 times I'm trying to find what? How many times I'll get female chicken? 5 times, exactly 5 times. But here in geometric distribution, this same scenario will change to wow, how? What is the probability I will get first female chicken if I'll try 10 times? Are you getting the difference here? There, total 5 times you want to get a female chicken. But here, what you are getting? Probability of getting your first success or first time when you get a female chicken. Are you understanding the difference here in geometric and binomial? So in geometric distribution is a probability distribution that represents the number of Bernoulli trials, each with probability P of success. So when I say Bernoulli trials, what does that mean, guys? This one. That means what? Bernoulli trials means what?
Binary.
Binary event. Right? Each with probability P of success, needed to get the first success. Now, same thing, but the way of calculating the probability for what? First success. And if this kind of questions you are answering or this kind of data you are dealing with, that comes under geometric distribution to calculate the probability of now that 100 times flipping of coin example. Can you tell me if I'll apply like how that become a geometric distribution? That 100 times and 25 times I want to be successful. Modify that to a geometric distribution definition that I just told you. It means what? I'm trying 100 times. What is the probability of getting first head? The first success criteria. In binomial, what we are calculating? What is the probability of getting 25 times the head? That means 25 times you want to be successful. And you are calculating the probability for that. But here you are doing what? Calculating the probability of getting first success. And what is the formula here? Very simple. Probability of x equal to 1 minus p x minus 1, where x is the number of trials you need to do to get the first success.
So we're gonna try 25 times to
Correct.
That's what, right?
Correct. Number of trials you need to get the first success. P is the, again, the individual probability of single trial.
Individual probability means like head or tail, right?
Yeah. Probability of success. P is, don't go for the events here. Here go for the success. Now you need to define your success criteria. Now I can change my success criteria. I'll tell you when I'll get a tail, that is my success criteria. I change my success criteria here. So this is P is what? The probability of success criteria. Now,
like how we define that success criteria, like we are the one who define.
We are correct. We are the
now.
one.
Okay.
As of now, we are the one who need to define the success criteria based on our data set we have and what questions we are going to answer. Based on that, you have to define the success criteria, isn't it?
Okay.
And if you give the same example of eggs and chickens, what is the question now? You might use the geometric distribution to determine probability of needing to incubate exactly 5 eggs to get the first female chick. So this is my success criteria. First success criteria after trying with 5 eggs. So what is x here? 5. So if I'll try to answer these questions, what I'll, for the first question, in place of x I need to put 5, in place of p I need to put 0.5. And the what value I'll get, that will answer that this is the probability, or there is this percent of chance that if you incubate exactly 5 eggs, you will get your first female chicken.
Okay, so in here, the P is going to be 0.5, right?
Yeah. And X is 5. So same second question, same thing, right? Trying at least 7 egg. So here, when I say
Ashish, like, sorry to cut you off. If you are going to write it like P of 25 equal to 1 minus 0.5
1 minus 0.5. So here X equal
to
to
the
5
power.
actually. So P of 5. Okay, P of 5 equal
Okay,
to 1
P of 5
minus 0.5. 5 minus
minus
1.
1.
1 into 0.5.
Okay.
Okay, so this is the formula.
Okay.
And here putting this into the formula. So be aware or be specific. What is your question here? Whether you want to calculate the probability of your fast success or multiple success. If multiple success, then which distribution you need to use? Formula? Binomial.
Binomial. Yeah.
If you are going for the first success criteria after trying multiple times, then in that case, Bernoulli, sorry, what is this? Geometric.
Okay, so it is also based on the scenarios, right? Like I want to know the first success rate or the you know probability of getting success.
Probability of, so question is probability of getting first success, that is geometric. Probability I will be 25 times successful,
Okay.
that is binomial.
Okay.
So to be honest guys, like these things like very confusing initially, but if we'll try to explore this geometric, binomial and all in the website or any blog, you will understand. So this is the simplest form we can understand now. If you refer the statistical papers and all, you're going to bang your head. What is binomial? What is Bernoulli?
Yeah.
Try it. Okay. So what you understood from this session, and whether that is similar or not. Okay. Try to explore. And I'm not only talking about this topic. Do it for all the topics that we're covering. So that your dimension of learning will increase, and that is going to help you a lot. Okay, so these are 3 known discrete distribution. Agree? Now let's see some of the properties here, okay, of this discrete distribution. This is called mean or expected value or expectation. All means the same thing. When I say what is my expectation on this data, you have to tell that you need to understand I'm asking about the mean value or the expected value. Now, why we need this? Why we need an expected value or the mean value of any kind of data we are going through? Why we calculate an average salary of someone? Like when we're trying to find out what is the salary he's getting, we're going for like what is the average salary last 2 years you are getting. So based on that, we are thinking and we are taking decision. Okay, this is the money that person is getting. So this average concept is like from the beginning of understanding. Like to understand something, you always look for a particular value which you can refer as a point, average point. Suppose I have a data of all the collected data from rolling a dice and all. So how to get some kind of conclusion on that data? Calculate the average value or the expected value, so that you will get a basic understanding. Okay, my data's average value is 5. So maybe the datas will vary from -1 to -5 to left hand side from 5 to right hand side from the 5, 0 to 10. So if I say my average value is 5, so maybe there is a chance I can see the range of what? 0 to 5. That's why my average value is coming 0 to 10. That's why my average value is coming as 5. So for example, I'm saying, so this kind of terms, expected value, mean, and expectations. This will give you an initial basic idea about your data. Do you agree?
So
And we
this
do it.
expected value means that 0.5 like that, right?
No, not that like that. 0.5 is the probability. Expected value is, we are not talking about probability here.
Okay,
Raw
so
data we have.
okay. So for example, like I'm expecting 5 should be an outcome for an event.
Right. So
Okay.
if you think in this way, suppose you collected salaries of 100 people. That's all you collected. Now you want to understand your data. The first point will do what? What is the average salary I collected from 100 people? That is the first thing you will come to your mind. You need to write the salaries and see what is the average value of the salaries you got, so that you can tell someone, based on this data, I can see many people from this 100 people are like this much average salary they are earning. To someone you can say like this makes your understanding, your the other person understanding also clear if you'll say like this. So basically these terms we are going to use in every distribution, continuous distribution, here in discrete distribution, how to calculate the average value of a data. So two things here. One, you plot the data and see the distribution. Second thing is try to get the average or midpoint or mean value of that data, so that you can say to someone, this is my data, this is the distribution it is following, and this is the mean or expected value of that data. So these terms we are learning to do what? To make the persons or the stakeholder understand this is the properties of your data that you have been provided me in your work environment. I'm saying, suppose, for example, guys. So we are here to do what? We are here to analyze our data and conclude something on our data. This is the mean value, this is the average value, and we're going to see what is variance and standard deviation. So those things is the statistical parameter that you need to calculate for every data. Now, in this case of discrete distribution, particularly, if you see here, how to calculate in a discrete distribution, how to calculate the expected value or mean value. This is what we are going to learn. So in probability and statistics, the expectation or expected value of a random variable is a measure of center of its distribution. Is this making sense to you? I am measuring the center of its distribution. That means what? If I plot my data and it will be something like this, it is following something like, so I am calculating what? The center value here. So that I can say most of your data points is around this point. Center of distribution. When I say expectations or expected value or mean value, I am pointing out towards what? Center of its distribution. Now in discrete distribution, how this center value calculated? It is a weighted average of all the possible values that the random variable can take. When I say weighted average, that means this formula. I'll explain this to you. Suppose the expectation of a discrete random variable x will possible values are x1. So consider this what? Rolling dice example. What is the possible values here? x1, x2 means what? 1, 2 to 6. And what is the probability of getting 1? 1 by 6. What is the probability of getting 2? 1 by 6. What is the probability of getting 3? 1 by 6. So when you multiply this value with the probability score, that is called your weightage, right? So you are not considering the value only, along with that the probability score you are multiplying. That's why it is called weighted value. Now this will be the summation. If I'll consider this part, if I'll put this is this, what is this sign? Summation. In mathematics, this sign means what? Summation. What is the sign for product? This means what? Product. That means these terms are summation of where I will vary from I to n. That means what? x1 p1 plus x2 p2 plus x3 p3, sorry, x3 into p3. Like this we are summating. So by instead of writing all these things, what we are writing? A summation of xi pi. I varies from 1 to n. So instead of writing all these things in a single mathematical, this is a mathematical way of representing what? Summation. Now this is how you are going to calculate the expected value of a discrete distribution using this formula, where xi is, so let me clear the screen. Consider our dice wala problem. What is xi? So xi will vary. Can you tell me in the dice problem this xi will vary from what? X1, x2. So I
X2.
is what? I is 1 to
X.
what is n here?
Okay, 6.
Okay, xi pi. This is for dice 1.
Yeah.
If I'll try to calculate how it will be done, xi means x1, right? X1 means what? 1. X2 is 2. So the possible values of the dice outcome, right? So 1 into probability of getting 1. What is that? 1 by 6. Plus 2 into probability of
1 by
getting
6.
a 1 by 6. Like this. Till how many times you have to write?
6.
If I'll 1 by 6, I'll take common. This will be 1 plus 2 plus 3 plus 4 plus 5 plus 6. So what is the value now? 3, 3, 6, 10,
21.
10, 15, 21. So 21 by 6.
Cancel. 18, 3.
6, 6, 3, 18, right? 30.
Yeah.
5.
Yeah, 3.5.
So the mean value of this distribution will come around what? 3.5. Okay, this is just to make you understand. I gave you the example. I'm going really slow, guys, to be honest with you, really slow. This is not my speed if I'll cover these things, in other batches, but for you specifically, I'm going very slow. Now, if you see here, this mathematical expression you understood. I need not to make you. Can you go through this and try to understand whether this is same what we discussed just now? What is n? What is xi? What is pi? Now, using this concept, we are going to solve some example here. You roll a pair of dice, and if the roll is less than or equal to 4, you win 5 rupees. If the roll is 5 or 6, you lose 2 rupees. Is it profitable? See the question here. That means what? What I'm calculating here? An expected value of this distribution. Or I am going to calculate a point where I can say if it is positive, that means I'm going to gain money. If it's negative, it is I'm going to lose money. Now tell me, what is the probability if I roll a pair of dice? What is the probability the roll is less than or equal to 4? Answer me this question. How to calculate the probability here? If you roll a pair of dice, how to calculate the probability that the roll is less than or equal to 4?
With the I'm not sure I'm right.
Try,
With the
try.
binomial.
Cumulative.
Oh, sorry. Yeah, cumulative.
Cumulative. What
Yeah.
do you mean by cumulative?
It's less than or equal to,
Now,
right?
this is not that CDA function, guys. This is a specific example. So what you want to, so you have 2 dice. You have to roll 2 dice. Okay. And the probability of getting the roll less than or equal to 4. So that is the CDF of one, one dice. Here we are rolling 2 dice, and what is the number we are getting here? That is less than or equal to 4. This is different. So how many ways I'll get if I'll roll this dice? How many ways? Either 1 will come here, 3 will come here. I'm
Yes.
calculating for 4. Okay, 4. This is one way.
Yeah. 3 will come here.
Another
1 will
way
come
is
here.
this is one way.
Yeah. 2, 2,
Any another way of 4 will come? 2,
2,
2. Any other?
4 will be there on the dice, right?
I'm combination of 2 dice I'm
Okay,
saying here,
okay, okay.
because
Sorry.
there's a rolling a pair of dice.
That's it.
That's it. Less than or equal to 4. Calculate same thing for 3. What is here? What is
2,
here?
1,
1, 2, 2,
2,
1.
1.
Any other
That's it.
combination? That's it.
Mhm.
For 2, what is the
1,
possible
1.
value? Here I am doing, okay. 1, 1. Any other combination?
Nope.
So how many ways? So this is my event space now. Event space, what is the event space? 1, 2, 3, 4, 5, 6. Event space is now my what? 6. This is the possibilities. Total event space, if you roll a pair of dice, total sample space, if you roll a pair of dice, sample space, guys, all possible outcomes. What
Yeah.
are the all
12,
possible outcomes? Sorry?
12,
Um,
12.
okay, okay. This is my 2 dice. When here is 1, here any number will come between 1 to 6, right?
Yep.
So how many ways? 6. If 2 will come here and 1,
36.
36. So that means in 36 possible ways, if you roll 2 dice, the numbers will come, isn't it? So my sample space is what? 36 here.
36.
Event space is 6. So
6.
if I'll calculate what is the probability of getting less than equal to 4, what is the answer? 6 by
36. Okay.
that is what?
6. 1 by 6 will
1
be the
by
answer.
6. So this is my probability. Okay. What is if the roll is 5 or 6, what is the probability? So till 4 we calculated this is 6. How many ways
Yeah.
we'll calculate 5 or 6?
5. We'll get 2, 3, 3, 2.
For 5 I'm saying, right?
Yeah.
1, 4.
1, 4.
Okay. 4, 1.
3, 2.
One thing. Then
Yeah.
2,
3,
3,
3, 2.
3, 3, 2.
That's
Then any other possible?
no.
Right? Okay. Now let's go for 6. 1, 5,
1, 1, 5, 5, 1,
5, 1, 5, 1.
3,
What
3,
else? 3, 3. Then
4, 2,
4, 2,
2,
2,
4.
4. Any other?
That's it.
So how many we have? 1, 2, 3, 4, 5,
5,
6.
6, 7,
Sorry, 3, 6, 7, 8, 9.
8,
Right?
9. 9
9
plus
by
6. Okay. So 5 or 6.
probability of getting a 5 or 6.
Okay.
What is the final answer? 9 possibilities of getting 5 or 6 divided by total possibilities, 36. So this is what? 1 by 4. Now, what is our original question? Our original question is to calculate the expected value. Okay, so here, what is my expected value here? What is xi here? The value of the event. What is the value of the event here? 5
Oh.
rupees.
Okay. Okay.
If this will the case, I will win 5 rupees. So x1 here is 5 into probability of getting that. What? Less than or equal to 6. This was 1 by 6, right? Plus, what is the second scenario? You lose 2 rupees. That means x2 is what here? Minus 2 into probability of rolling 5 per 6. This is what is that? 1 by 4.
1 by 4.
So now this, what is the result will come? This is your expected value.
5
Okay,
by
that means
6
5 by 6 minus 1 by 2.
minus 1 by 2.
So this will be your what?
4.
5 minus 3 by 6. This will be what? 2 by 6. Again, it will be 1 by 3. 1 by 3 means point. So that means you are getting a positive value here, isn't it? So there is a chance that you are going to, this is not certain. There is a, so when we are dealing with probabilities, we are dealing with uncertainties, isn't it? We can say like this is the possibility, because as I am getting a expected value around this, so maybe you will be profitable. Now suppose you roll the dice and by your unlucky, you are not lucky that day, and only you got 5 or 6. So when you roll pair of dice, every time you are getting the number more than 5 or 6. That time what is the outcome? You will be totally losing the money. So this 0.33 is what? This is giving you a initial starting point. Okay, if I'll do this, there is a chance that I'll be profitable. 0.33. If this value will come as minus 0.33, that means what? You are
I'll
not
be in
profitable.
loss. Yeah.
You are in loss. So you are predicting, you are based on this formula, you are trying to predict, is there any chance that I'll be profitable? Yes, the answer is yes, because it is coming as 0.33, but that is not guaranteed. If 5 or 6 will come multiple times, then that time you will be in loss. So this expected time, expected value or mean value will give you an intuitive idea or an overall idea what is going to happen or how the data is going to vary. So around this point. Now let's see with another example so that your if any confusion, it will clear in the second example. Suppose there is a 20% chance of 1 inch rain, 70% chance of 2 inch rain, and 10% chance of 3 inch rain. Tell me the expected value or the mean value or expectations of this rain distribution or the amount of rain that we are going to get. What is xi here? What is pi here? Tell me. That's what you need to identify here. 20% chance of 1 inch rain. That means what? This is the probabilistic value. So P1 is what? 0.2. X1 is 1 inch. Similarly, X2 is 2 inch. P2 is 0.7.
7.
X3 is 3 inch. And P3 is 0.1.
0.1.
Now how to calculate the expected value?
0.
1 into 0.2 plus 2 into 0.7 plus 3 into
0.1.
0.1. Now whatever is value we'll get, this is the mean value or the expected value of amount of rain that you are going to get.
Okay. So for rolling a dice and all those, like we have to look for the probability and then we need to calculate. But like when we were given with the values, like we can just go ahead and easily apply that formula and then we can
Correct.
get.
So here the value you are defining 1 inch of rain, that is your value. In the rolling dice, you are defining getting a number, that is my value. Getting a number means what? Either you get 1 or 2 or 3, any. This is the value. This is also the value. This is you defined 1 inch of rain. This is my value. And this is the probability chance. And if this happens, then what I can expect from this data? So I can expect.
Okay, so in
this.
For the above question, what is the probability chance there? Like it is 4, right? 4 and 5 or 6.
There you calculate the probability.
Okay.
By what is the probability that you will get 4 and 5? Here the probability value already given to you.
Okay. Okay.
20% chance of 1 inch rain. Probability and its value. It's already given to you. Here probability was not given, but the value was given 5 rupees, 2 rupees. Are you getting the difference here? Here probability value and the specific value also given to you. Here only value like xi part is given to you. So pi part you calculated, getting less than or equal to 4, getting 5 or 6. There you calculate the pi. Understood? And this expectations or mean value have some properties that you need to understand. Why we need to see these properties? Now we are talking about a single event here, that rolling a dice or amount of rain. Consider multiple events are there. Now you are rolling a dice, you are spinning a coin, you are also playing a roulette wheel also, because all this example we are seeing, we are like doing in that casino, right? So consider you are doing multiple events in the casino. You are going for the card game also, you are going for the roulette wheel also, you are going for spinning that wheel also. Now all these events, if we will combine, what is the expected value? There you have to use the properties of expectations, or else every time you have to calculate individual event expectation, then you need to conclude. But if you will understand the properties of expectations, you will easily derive of all the events. No need to calculate individually. For example, linearity is a property. What does this mean? The expected value of a linear combination of random variables is equal to the linear combination of their expected values. For example, if X is spinning coin, Y is spinning roulette wheel, right? Two events. Then expected value of X is you calculate using this formula. Expected value of Y also you calculate using the formula. We do this. Now what is the expected value if I will spin the coin 5 times? Also spin the roulette wheel 10 times. Are you getting the point here? So I am calculating. Initially I was calculating for the single event, but here I will try to repeat that event. I'm spinning the coin or spinning the wheel, but I will do 5 times. Then what is my expected value? So you calculate the expected value while going for 1 time, and you multiply that with number of times. So if an expected value is around 0.2, here I will multiply with 5. So 5 into 0.2 for X event. If I'm going to repeat the second event 10 times, then plus 10 into the expected value of single event. So for suppose roulette wheel, it is 0.3. And if I'll do this 5 times this one, 5 times 10 times this one, this is my expected value. That is linearity. Why this is called linearity? Because AX plus BY, linear combination of these two variables. So if you are going to calculate on this, then this should be the properties. You multiply into number of trials into the specific expected value. Now once you understand this two property will be easy to understand. This is same thing. So combining this two property, we got linearity. You will see that. Just 1 minute. Let me scroll. Now can you try to understand constant scaling and additivity? Just read it and try to understand. And it will be the combination of these two is nothing but this one. Is it correct to say that? Can you read it? Constant scaling and additivity. Meanwhile, I'll drink some water, guys. So guys, you understood constant scaling? Same thing we are doing, right? So if you take only this alpha into e to the power x part, this is same, right? If you omit y here, this is same here, right? That means what? If I'll try to repeat number of times, then the expected value will change what? Number of times into expected value of the single trial. Isn't it? Same,
True.
isn't it?
True.
And here also, if you see here, the difference of
Ashish, can you please tell the linearity once again? Like if I'm coming to the another topic, the previous topic was
no.
it's
So
like
the
rubbing
only
a foot.
way you can do it, explain what you understand.
Okay.
First, try to explain what you understand. Then, because this is not like one go, you can't get it. Okay, so go it by chunks. So tell me what you understand in linearity.
Okay, so in linearity, we'll get the combination of expected values. Like for example, we were doing two events at the same
Events,
time. Yeah,
correct.
two
Hmm.
events at the same time. For example, like as you said, rolling a dice and then the spinning a wheel. So we'll have the expected values, right? Like zero point 0.5 for dice and 0.3 for the wheel, as you said. So like we correlating with that. Like if I'm doing it one time, 1 into 0.5 plus 1 into 0.3. If I'm doing the dice two times, then 2 into 0.5 plus 1 into 0.3 as I'm rolling, spinning the wheel once. So that is the linearity, right?
Yeah, and why we're calculating that? Because we want to know what is the expected value if we'll repeat this 5 times, if we'll repeat this 10 times, isn't it?
Okay, so I'm
The,
performing two events at the same time, but I want to know what will be
what
the
is my
expected value
expected value?
of two events happening at the same time, but the two events maybe happens like for example, rolling a
Multiple
dice
times.
maybe 10 times. The
Correct.
spinning a wheel might be 5 times. That doesn't the case. Like two events can happen 10 times or 5 times. Either it should not be same, right? If
Correct.
I'm having two events, it doesn't like for calculating linearity, it doesn't need to be same, right?
Hmm.
Like if I'm rolling the dice 10 times and spinning the wheel 10 times, it doesn't need to be the same. It can be 5, it can be 10, it can be 10, it can be 5, right?
Yeah, so that number of times trial is up to you, 10
Mm-hmm,
times or
mm-hmm.
5 times, but the question is what at the end what you are getting, what is the expected value by doing all this drama 10 times and 5 times.
Okay, okay.
So instead of going calculating one by one 10 times, use the linearity property of
Mm-hmm.
expectations and answer the question quickly.
Sure.
And if you see here, constant scaling is, we are doing constant scaling in linearity also, where if you see, expected value of a into x is what? A into expected value of x. Here constant scaling means that only, that you are repeating that event 5 times, that means the expected value will be 5 into expected value of one time trial. And additivity is also, we are doing what? If we are combining two events and trying to get the expected value, suppose I am playing roulette wheel, I'm spinning the wheel also, this two event I'm doing simultaneously, and then I'm calculating the total expected value of this plus this, then this will be indivisible. So if you see here, if you observe carefully additivity and linearity, if I'll make a and b one, whether it will be same as additivity formula, a and b 1, isn't it?
Yes. Like
Right.
these three, yeah, these three has similarities, right? Like if
So,
you if
so in
you
a way you can say constant scaling plus or constant scaling and additivity combination is linearity. Can I
linearity,
say that?
okay. Yeah, yeah, yeah.
So these are the basic properties of expectation. So we have also example to demonstrate this. Suppose X is the random variable that represents the amount of money we are going to win or lose in a single roll of a dice. X is what? Here you are defining your random variable is a what? Amount of money you are going to win or lose in a single roll of a dice. If you roll 1, 2, or 3, you will win 10 rupees. If you roll 4, 5, 6, you will lose 5 rupees. And now how is the expected value can be calculated here? 10 into why 3 by 6? Can you tell me why 3 by 6?
1, 2, 3.
The
What
three
is the
outcomes are
probability?
there.
So 1 by 6 for 1, 1 by 6 for 2, 1 by
Yeah.
6 for 3.
3,
So
yeah.
that is 3 by 6. Plus, you are going to lose 5 rupees. That means what? Minus 5. Into 4, 5, 6 also 3 by 6.
Yes.
So the expected value is your what? 5 rupees. That means you are going to gain 5 rupees if you will because that makes sense, right? 10 rupees when 1, 2, 3, and 4 rupees, sorry, 5 rupees when 4, 5, 6. So overall will be, if you think you are lucky, like same times 1, 2, 3 will the number of times 1, 2, 3 will come will be equal to number of times 4, 5, 6 will come, then you are going to be profitable. But if you are not that much lucky, only 5, 4, 5, 6 will come, then what? Maybe you are going not to. So this is the overall idea, average or the expected value that you are going to get.
Okay.
So if everything finds, you have a balanced luck that day, you are going to be profitable. This is what it is saying. Now this is not end here. We are understanding linearity, right? So this is one event. Another event is you are now like doing what? Another thing you are doing, which is y. This is event is y, which represents the amount of money you are going to win or lose in a single spin of a roulette wheel. So roulette wheel, you understand, right? That you have seen this in movies, right? The wheel will roll.
Will spin and we'll get a
And then you
prize.
will put a ball, right? We'll put a ball and you will say like, okay, at this number it is going to fall.
Oh,
So you are
that's it.
performing,
Okay.
so you are performing two actions in that day. One is X, one is Y. And if the ball lands on an even number, you are going to win 20 rupees. If the ball lands on odd number, you are going to lose 10 rupees. Now, how to calculate the expected value here? What is the XI here?
20.
What is the probability of getting even number?
1. There is a 2 course of events, like odd or even.
Right. So what is the probability of getting an even number out of even
1.
and odd? 1 by 2. Like same thing as head
Yes.
and tail. What is the probability of getting head? 1 by 2.
1.
So out of even, not 1, Dinesh, 1 by
Sorry,
2.
1 by 2. Oh, sorry.
So 20 into 1 by 2.
Okay.
20 is the value and the probability value is 1 by 2. Plus 10 you are going to lose, minus 10 into getting odd number. That also 1 by 2. So
1 by
5
2.
rupees again. Now to explain linearity, what I am doing, I am playing 2 times this game and 3 times this game. Now, if
Okay.
I'll do this, what is the expected value I'm going to get from here? Now here you can use the linearity equation because you now got the individual expected value, Ex and Ey, right? The only thing you are doing what? 2 times you are playing X, 3 times you are playing Y. So
Yep.
what is this? Expected value will be 2 into Ex plus 3 into Ey. That is 20 rupees. Like if you will perform this, you will play the first game 2 times and second game 3 times. I think I don't want to explain the constant scaling here. Example of constant scaling. Constant scaling means what? You are like go for one event and do that for multiple time. Then the expected value will be what? Multiple time, that how many times you are doing that into the expected value.
We did the constant scaling, in the
Here
above
also.
example, we did the constant scaling and then only we came to the linear formula,
Correct.
right?
Yeah. So why this is linear? Because this 2x and 3y is the linear combination of the
Okay,
mathematical
so
equation.
finding the EX and EY is the constant scaling, right?
Correct.
So if you want to
No.
find
Finding 2x is the constant scaling. Constant scaling means what? You are scaling this event 2 times. That's why 2 is a constant here.
okay.
So that means when you are
Then what is
scaling
that
2 times,
finding of EX and EY? Like what do we call that?
this is like individual expectations. Like when you do it for one time, what is the expectation?
Okay.
Just only one time. You played that game only one time.
Okay.
But when going to you play that game 2
Ashish,
times.
can you please go up to that expectations?
And also guys, it is 11, so let's not continue from here. If you guys, and tomorrow is a holiday, right guys? You know, right? Tomorrow we don't
Friday.
have it. Tomorrow we are not going to have the class. I got a mail from the management.
Is that so?
Idul something is there, right? Tomorrow.
Yeah,
Eid.
Eid.
Oh,
Eid.
okay.
What is it?
So because of that, sorry.
Eid Mubarak. Yeah, holiday
Thursday is a
announcement.
working day, no?
No, holiday announcement. Like if we check that
So I
email.
got a mail
Yeah.
saying that tomorrow is a holiday from Govi side.
Yeah.
So that's
Yeah,
why we
dear
won't be
Lana.
having
Yeah,
any class.
same. So on Friday we won't have any classes.
Yeah, again. So this is a long holiday,
Okay.
Long weekend.
long weekend.
Like we
So
won't call it as long weekend. Like if it is in
weekend
office,
for
then it
like,
is fine.
so yeah, in the corporate life we are like very happy with this weekend stuff now, but in the
Yeah.
freelancing there is no weekend or any weekdays for me. Anytime can be a weekday, anytime can be a weekend.
Okay.
Okay. So for me, actually, I'll get some time actually. So that's why, like, I know people will start leaving now. Already few of
Yeah.
them left. So hopefully we'll get the mail that there is no class. Please confirm this once.
Yeah, I've already and mail was there. Like I think yesterday itself they have sent. Now only I'm just going and checking an email. God.
Okay.
Yeah.
Okay. So we'll start from variance
Variance.
tomorrow.
Okay.
Okay. Not tomorrow.
I mean Monday.
Monday from variance.
Okay.
Okay. So we will, because from here some deeper understanding will start from your so many things,
Oh
statistical
God,
things.
like there is a lot of
Okay.
mathematical stuff. I'm like
So
my
this is what,
stomach
as per
got
your
rumbling.
so this is what you need to do if you're going for this role. No, I know
Mhm.
I'm not sure what is role you are choosing here, but I can suggest don't think of any particular role right now. Complete the course without thinking of any role,
Mm-hmm.
because try to explore the things rather than only some. I know few of you are particularly aiming for data analyst, right? But don't do that stuff. Complete
Like
this one. Maybe you will get another good role as per your convenience. Don't
okay.
restrict your mind for a particular role right now. I'm saying complete
But
this
Ashish,
course.
but the kind of knowledge what we have, the entry level is data analyst only. What can else we dream of apart from that?
Data scientist, it is not so do a data analyst does this statistical analysis,
No.
like plotting the curve and showing the distribution? That is a job of a data scientist only, because there's mathematics involved here.
Okay.
I get you on that, Ashish, but see the typical career path, what I have observed from my research is starting point, the step one is the data analyst only.
Yeah, starting point is a data analyst only, but that is not the rule, right? You can jump to a DS role directly.
Yeah. So like as
Like
as I've okay.
I was an IT analyst position, not data analyst. Overall data analysis also I was doing, the overall business analysis also I was doing. So I jump to next data scientist position. So
Okay.
data analyst can be, so data scientist can do lots of people's work. That's what I'm saying here. Data analyst work
Yeah.
also you can do, data engineer work also you can do. So you have to have a combined knowledge on every role.
Okay, so data scientist is kind of a guy like who will do the data analyst job, business analyst job, the data scientist job, and the
Like,
developer's job and everything.
like it is not mandatory to do, but the data scientist should have knowledge on this sector so that
Okay.
any requirement immediately data scientist can join and help the team.
Okay, so data scientist is the guy who have more knowledge in the mathematical and the curves and all
Functional,
those, as you said. Okay.
functional point of view also.
So what this data analyst guy will do?
Data analyst will be to analyze your data and derive the things, but here as a data
Okay, so
scientist you analyzing
analyzing the
building
data
model,
and classifying into
building
a.
model.
Okay,
Yeah,
okay,
you are building the model also, still not left, still not finished, guys. After building the model, you are deploying this to a production server also. If that is, if required, a data scientist should do that.
okay. So data architect will not do all those, like data architect or data
Yeah,
engineer will not, don't do all those, like deploying and creating a server and maintaining all those. Like that is also a data scientist guy will do.
yeah. So data scientist can connect with
Okay.
multiple teams here, from data analyst team to data engineers team to development team. Any team the data scientist can connect to, because he has the knowledge, although he is
Okay.
not going to do every job, but he has the
Okay.
knowledge. He can help you out with anything in the end-to-end flow.
Okay. It's kind of an Instagram meme reminds me. Okay, fine.
Right, memes remain. So basically, like data scientist is the thread to connect the,
Okay.
you know, the what I can say, the garland. The flowers are those
Yeah,
roles,
yeah.
and data scientist is the thread which can
Okay.
connect people. So the point is here, why I'm saying, like, first you finish this one. Once you finish, you have a broader exercise of your brain. So many things here, like
Okay.
mathematics,
Okay.
everything. So once the exercise is done, your mind will be flexible to adopt any kind of role.
Okay. Okay.
And
So
that time
data
you have
science is
more.
also kind of engineering. You can do engineering and then you can
Anything
become
also, yeah.
everything.
See, it's all about like your interest. Suppose you got
Okay.
bored by doing this plotting stuff. You want to switch to engineering role. You apply for the data engineer role in, because you know the stuff, right?
Mm-hmm.
So I'm not talking about 1 year, 2 year here. It is a future roadmap plan for you.
Okay. So
That's
like
why.
all you're trying to say is like don't sit on data analyst, like try to gain some knowledge even after you're getting a job and switch somewhere and do exploring, right?
Yeah. So what I'm saying, focused on this whole course till the whole course finish. You don't, consider any positions. Just finish the course with 100% of your effort.
Okay.
Okay.
Sure, Ashish.
Then you decide, because there are also, like, if you'll go, like, deep learning also comes into picture after a few sessions. Okay.
Mhm.
There, if you'll see, like, okay, you are very enjoying by looking the pictures and doing the analysis on pictures, you go for computer engineer role. Now that is
Okay.
totally different from data scientist job.
Okay.
So there is lots of doors actually in front of you. You are just
Yeah, and
cracking.
also I've seen and did some research. Then, like once the machine learning comes in, then it'll be so interesting. Like SQL and MongoDB, we were all like little bit
Ah,
enthusiastic, right?
we'll
Like
we'll see
machine
that.
learning comes.
We'll see that from you. What is the
Like
enthusiasm you are bringing
I've
today?
seen like that, but I'm not sure that like
Okay, so, but yeah, good thing, good thing. If you're keeping this mind, I don't want to discourage you. Like,
yeah.
but yeah, it is going to trouble you, but that trouble is good for you. What I felt,
Okay.
I mean, enormous nights I have sat in, like, without sleeping, and also I can see the difference right now. That time I want, it's like, oh, this is too much. Few people I have
Okay.
seen also, they left the course, not here in where
Okay.
I was doing. People will start initially with enthusiasm, then they will left the course, like, once this, too complex thing started. So they
Okay.
put that in mind that it is complex. Actually, it is not complex.
Yeah, actually, I faced it. Like yesterday, I was like, okay, I have nothing was understanding, nothing was understanding. So for the whole class, I didn't, like had that
Hmm.
much in my mind. So today, I
So
was
don't
like,
don't stress out. Just
yeah,
give it a time and stick to the plan. Eventually, you are going to get it. That's what my
sure, sure,
thinking here. So
sure,
don't
Ashish.
don't restrict yourself with the starting of the course. Finish
Yeah,
it, then you decide which path you want to go. Data
sure, sure, sure.
analyst or data scientist, computer vision engineer, data engineer. Then you decide.
Okay.
Okay. And Divya is here or Divya left? Divya, are you here?
Yes, sir. I'm here only.
Okay, okay. So I think yesterday we had some unfinished business, isn't it?
Yes, sir. Yes, sir. Yes, sir.
So what I did actually, I wrote the whole query again and I uploaded to our data folder here. If you
Okay, sir.
see that session, what is the session? Today's session, I think I didn't upload. That means
2 days
day
before.
2 days before, that is 26th then, right? So 26th folder I have updated the text document today. If you go to
Okay.
that part in the data relationship, here this reference one to one, one to many, can you try to
Yes.
open and execute in your system and let me know whether it's working or not?
Yeah, sure, sir.
So reference one, and here I totally changed the query here. I made it you know, Jupyter friendly query, not that MongoDB. Initially it was inside Mongo database, right? MongoDB the
Yes,
query,
sir.
but I wrote it according to Jupyter notebook. So
Oh, after some time, I also watching that code that we are trying to join two tables. As yesterday, as per yesterday, just we are retrieving the user input only. We are not getting that personal details of the first table.
So to mitigate that, if you share your screen, I'll implement what I have written here. First go to, so it will be easy now. I made your work easy, you know, to do this. You just copy this and try to understand and tell me or show me
Sure,
whether
sir.
it is working in your system or not. Because I tried it and this morning it is working. I am able to fetching the
Yeah,
details from
sure.
the database. Yeah.
Yeah, sure, sir. But that share screen. I'm sharing my screen now.
So do one thing. You open that text file and copy the code from
Yes.
there instead of doing all this, so it will be easier. Then you can manipulate with that by changing the variable name and all according to your.
Okay,
So
sir.
I just wanted to see that code is working in your system, that's all. Then if you want to change the variable and test on your own, you can do that later.
Yeah, sure, sir.
So in the G drive,
Yeah, I'm just in my mail, I connect with that. Yeah. I'm not open there now. So
you can bookmark this, no? You can bookmark this one. Do one thing.
Just click on the start button, then it will be.
So if you will click, just bookmark this one, no? The right hand side star button is there, right? In the tab.
Yes, sir.
Not here.
Not that one,
Up.
Divya. About to that. In that search bar there, right?
Let me annotate. Here. See here.
Yes, sir.
Okay, click that star button. It will bookmark that page for you.
Done.
Then next time you you open a new window or new tab.
Just
Open
click
a new tab.
Ctrl T or else click on new tab.
Okay.
Click on new tab. Here, if you see where it is.
Just click on that arrow button, like
here. Click here.
yeah, that's there.
Click here. Here, if
Now
you
you can
see.
Session 2. She has a lots of bookmarks, it seems.
Yes, I'm having lots of that important.
Then, like, you know, take a notepad and then take a notepad and then, you know, paste all those. Then it will be easy, right?
Okay.
You can do that later. Let's go to that share folder of G drive.
Okay, I was just like let's see on Monday. Happy weekend.
Guys, those who want to leave, please go.
Happy weekend, guys.
Holiday. Happy weekend. Okay, guys. So reference 1-1.
This one is correct.
Now if you see, copy the first part. Not this one. from the starting to the before the stars.
Excuse
from
me, sir.
there.
Just a minute. Just a minute.
Yeah. Or else what we can do, Dibya, you copy this, okay, and try to implement in your code. I'm not going to guide
Yes,
you.
sir.
You just do it. You just do it. Or you do it, try
Okay,
it,
sir.
and let me know on Monday, because this is going to work.
Yeah, sure, sir. I'll try, sir.
Okay. So if you are busy or
Oh.
for doing something, try it in your.
No,
free
actually,
time.
I kept my mouse in that room, so I went and
Okay. Then try. Okay.
take
Then
the-
try. So here, what you are doing? Can you try to understand here? What you are doing from the starting? Make me
that
understand from the
in
starting line.
the yes, we have created two tables. That the reference personal details is one table, and that we are storing in that reference personal details variable, and reference user is another table. We are storing in the another variable referent user.
Correct.
And
Now,
the details are the here are the here we have the details.
Now the inserting part you make in a different cell. Below to that cell, cut paste,
Yes.
select this part till the last one.
It's okay.
Okay, now first run that cell, first cell which contains your table. Run this cell. My DB is not defined. Define the DB and connection. Define the connection first.
Yes.
Go to the top. Here. Remove the last two lines and run that cell. And now run this cell. Okay.
Yes, I have run.
Okay. Go to the last. Yeah. Now run the cell that throw you the error.
Yes, sir.
Yeah, it's working. Now run that cell.
Yes, sir.
Right. Okay. Now go to the text pad. In the G drive file, the last part you copy. Correct. Then you paste in that Jupyter cell. So the code part you understand, you are getting, right? Let's first implement, then you go through the code. So Jupyter notebook here. Now run the cell. Now you're getting?
Yes, sir. Yes.
So basically we are getting an embedded document here, right? Using two collection.
Okay.
Similar you try for one to many and let me know on Monday. Okay.
Okay. One to many means also we have to create two tables, and then like the way we have to run this, right?
Yeah. The code is also I provided. You need not to worry. You just the table code and all everything I provided. You just understand the code.
Yeah.
The
Okay. Sure. I'll try, sir.
You have to explain me. If someone will ask you, explain me the code, you will be able to do that. That's the point here.
Yeah. Sure, sir. Sure. I'll try.
Okay.
Thank you.
Okay,
Thank you.
let's see.
Thank you.
Thank you, guys. Any other questions from anyone?
Actually, today's that probability part is much more difficult. Actually, all the session have understood very well, but this session is very difficult, I think so. But we have to try. This is what I thought.
Right.
Okay, sir.
One secret weapon I'm going to giving you. How many people? 6 people are there. Okay, start enjoying the difficult. Then only
Yeah,
you can
sure. Try, sir. We will try our best.
Yeah. And no, this is not difficult. This is only because you are seeing this for the first time.
Thank you.
Yeah. So okay, we'll see. Okay, Monday.
Okay, thank you, sir. Thank you.
Thank you guys. Bye.
Yeah, thank you.
Thank you.
Bye.